In this lecture, we are going to see a lot of small topics which are quite basic things in our subject control systems. Now quickly take any example of transfer function. The roots of the numerator or the values of Laplace variable s for which the transfer function becomes 0 are called zeros of the transfer function or the system. As such, the zeros of the above transfer function are -9 and -5. Similarly, we have poles which are also referred as singularities, which are the roots of the denominator, or these are the values of Laplace variable s for which the transfer function becomes undefined. Poles for the above transfer function will be -4 and 3. We have seen that we have two types of control systems. One is open loop control system and the other is closed loop control system. The general representation of an open loop control system is like this, where y and x are output and input and g is the transfer function of the system, and the term g is referred as open system transfer function. Now consider closed loop control system. In this type of control system, input x is connected to a comparator which is represented by a circle, and after that the signal from comparator goes to g, which is referred as feed forward function, whose output is fed back to a feedback function. This circle is referred as summing point, whereas a simple takeout from any branch like shown is referred as branch point or takeoff point. This is the point from where we get the error signal, and this is the point from where we can find the feedback signal if required. In the shown diagram, you can see in the circle there are two signs. One is positive, one is negative. The input is fed with positive sign, whereas the feedback signal is fed with negative sign. The input is always assumed to be fed positively. However, the sign of feedback may change. Depending upon the sign of the feedback signal only, we have two different systems. The one which is shown on the screen is an example of negative feedback system. The equation for error signal in this case will be equal to Laplace transform of the input minus the Laplace transform of the feedback signal. But if the feedback signal was fed with positive sign, then the system would be said to be positive feedback system. Considering negative feedback system, we will see few more terms. Now suppose if we have to find the transfer function of this configuration, then we have three equations. The first is for error signal. The second is output will be equal to error multiplied by feed forward signal, and the third is Laplace transform of the feedback signal is equal to the Laplace transform of the output multiplied by Laplace transform of the feedback system. Putting the value of error signal from equation 1 into equation 2, we will have this equation. Now we will put the value of feedback signal Laplace transform from equation 3 to equation 4, giving us this equation. Simply rearranging this equation, we will get the transfer function or the Laplace transform of the output to the Laplace transform of the input to be equal to g divided by 1 plus g into h. We have found the transfer function, but if we are talking about closed loop control system, then we actually have two types of transfer function. One is closed loop transfer function and the other one is open loop transfer function. In this case, where the loop is closed, the transfer function is simply said as closed loop transfer function. If in a question, if the term used is only transfer function, then you will assume it to be closed loop transfer function. But we have open loop transfer function also, which is found by first disconnecting the feedback signal from the comparator and also changing the position from where the output is taken. In this case, if we try to find the transfer function, we will find it to be equal to Laplace transform of the feed forward system multiplied by Laplace transform of the feedback system. This transfer function is referred as open loop transfer function. Now suppose, what if the Laplace transform of the feedback system is equal to 1? Such type of control systems are referred as unity feedback control system, and in such cases there is no need to show the feedback system with the help of a block, as a straight line also means the same. I have considered only negative feedback system, and as a practice, you should try to find the closed loop control system and open loop control system for positive feedback system. Cross-check your results from the short notes attached in the video's description. You must go through the short notes as you may also find few shortcuts for solving numerical problems. So we have seen what are zeros, poles, what is open system transfer function, what are feedforward function, feedback function, summing point, branch or takeoff point, and we have also seen negative and positive feedback systems, and we have seen that we have actually two types of transfer function for a closed loop control system, which are closed loop transfer function and open loop transfer function. We have seen what are unity feedback system, and I hope you have understood each and every point.